Hey everybody, welcome back. At this time, we'll be learning the physics behind a rocket. Do you want to know more? Let's hit the ground running. The first part that we need to know is which are the forces that we can find or that we can use on this experiment, right? Or that we are going to be handling, the forces that we will be handling, right? The first is one call it gravity. That gravity plus air friction plus weight, those are the forces that I need to be against for, right? I need to be higher than the sum of gravity, air friction, and weight, right? Then that's the main point. Those are three forces that are assumed and that I need to be higher or that I need to overcome in order to take off, right? So if I want to take off, if I want to take off, I need to have an opposite force, right? Then this opposite force is called thrust. Thrust is the force that have to be higher than gravity plus air friction plus weight. Then the thrust is the force that will be produced by the engines, right? That's the thrust force. That's why I need a lot of fuel right here. Then the second, then we already know this, okay? The first part is that gravity plus weight plus air friction, those are the forces that I need to overcome in order to take off, right? So to take off, I have the force called thrust. Thrust is the force to uh, to take off, right? That's it's an opposite force, opposite of who? Of gravity plus air friction plus weight, right? Then the second Newton's law, that's a good point here because how this equation is going to be used here. Force equal mass per acceleration. And we got to know acceleration is inverse to mass, right? Is if I have an object that have more matter of more volume or more mass, the acceleration will be less, right? Then that's why the second Newton laws is applied here. That also this force has to be higher than for gravity, air friction, and weight, right? But here we can consider that if it has too much weight or too much mass, the acceleration will be inverse to weight, right? Then more acceleration, less weight. More weight, less acceleration, okay? You got it. And now we gotta check about the third Newton's law because there's an action versus a reaction. What is the action? Thrust. What is the action against? The action is against the gravity, earth friction, and weight, right? And record this, the third Newton's laws say that the action of the thrust or the thrust react action of the thrust force will be or will have this reaction. What is the reaction? Take this off. Roger? Then we already got it. In this point that we have no takeoff yet, what are the forces? Okay, the forces are the three main forces. Okay, three main forces. That is gravity, weight, air friction. Gravity, weight, air friction. What is the positive force? But it must be the same longitude, the same. Gotta be this, gotta be, and this called thrust. You gotta have the same amount, right? Here, the sum of them, the gravity, the weight, and the air friction, it's equal thrust, right? That's why the vectors has to have this. If the sum of the three has to have the same amount of thrust, right? Now, in B point, we already know what is the force here. Here's the kinetic, in the A, the kinetic energy is 0 because it has not taken off yet. The potential energy is 0 because it's still underground, right? Here, when we are on the space, okay? Also recall, it will start accelerate in mass to the mass. Right? More mass, less acceleration, right? When we are on this space, we gotta recall that no friction, right? This fact will produce an eternal motion, right? Eternal motion, the first Newton's law, inertia. An object in motion will stay in motion. Now you already know this, okay? The first Newton's law, inertia. Here is applied the inertia, right? At this point, at A point, we are applying two Newton's law. Second Newton's law because the acceleration will be inverse to the mass. And it will start accelerating, right? And at the force is equal to the thrust, but the thrust must be higher than the sum of gravity, air friction, and itself on the weight, his weight, right? Then that's the logic. And here we are applying the first law, inertia. Then we are applying here the 3 Newton's law, inertia. Why? Because when this rocket has already taken off and when it's getting into the space, this space has no friction, and it means that the first Newton's law will be accomplished. What is this first Newton's law? Inertia, right? The inertia is the first Newton's law that is saying that an object in motion will stay in motion until an external or a positive force will stop it. And also we have to recall what is the another meaning of this. That is, an object in rest will stay in rest until a positive or an external force will change it. Oh my goodness, that's why we gotta record this, right? Inertia. Then we are accomplished 1, 2, and the first, second, and third Newton's law, right? The three Newton's law. And when it's taking off, when under here, right? Here, the potential energy is maximum, right? Because it has the maximum weight amount regarding our ground. Then its maximum is max and increasing because the distance of weight will be higher, right? And the kinetic energy is maximum as well. That's why when this system or this object gets up to the max speed or to the max kinetic energy or potential energy, the motion will be eternally, and there's nothing that max. It just has to keep being max or just decreasing, start decreasing, right? Then in the space, potential energy max and kinetic energy max, right? And if we are going to go back to the air, right? At this point, the kinetic energy is maximum and the potential energy is 0, right? Because it's falling, right? Because it's falling. If it's falling, it's being accelerated, right? The kinetic energy will not be stopping or will not be decreasing. No. In other hands, it will be decreasing, it will be higher, right? Then that's why when I take this off, then we are going to resume this, but let me please grab one, okay? I guess that I got. I've created one. It's not my best one, okay? Look at this. I have this rocket here. Then on the ground, we got to recall this, okay? On the ground, we have to overcome three main forces: gravity, weight, and earth friction. And the force that will overcome the sum of all of them is equal thrust. That the thrust is the force that have to be higher than gravity, air friction, and weight, right? And also the thrust is the force produced in or by an engine, right? Here we have this object here, and when we take off, the thrust force has to be higher than the sum of all of them, right? When it gets into the space, the motion will be eternally because there's no friction, and we can accomplish the first Newton's law, inertia. Eternal motion, eternal static. And when before taking off, right, it gotta be in this way. Before taking off, the kinetic energy is zero, the potential energy is zero, and the thrust energy the thrust force has to be higher than the sum of the gravity, or friction, and weight, right? Also, when before taking off, we are accomplished through two of Newton's law, which are them, the second and the third, right? The second is saying that the force is equal mass per acceleration. And the third is saying that action reaction. Then why we are saying this second Newton's law? Because the force is equal mass per acceleration. But in this case, acceleration is inverse to mass. More mass, less acceleration. More mass, less acceleration. Hope you have got it. If not, comment, ask your doubts on the comments below, and I will be more than glad to help you out. If you have liked this class, give me my thumbs up, right? Then let's record this. The third Newton's laws are applied here. The first Newton's laws is the inertia. When is the inertia applied in this case? When the rocket is getting into the space, because in the space there's no friction and the motion could be eternally, and the status could be eternally as well. When before taking off the rocket, we also have, or we are accomplishing the first and the second and the third Newton's law, that is saying that the force is equal mass per acceleration, but also we are saying that the acceleration is inverse to the mass in this case. So, and the third Newton's law is saying that the action of the thumbs of the thrust force, the action is the thrust and the reaction is taking off. That's why we are accomplishes the third Newton's law as well. So if you got some questions, don't hesitate to ask on the comments below. I will be more than glad to help you out. See you in the next video, and record this. It's time to crack the box. See you there.